Okay, so we're going to take the composition f of g of x. Here's f of x. Here's g of x. So we know we start this by saying f of g of x, and then we replace g of x with what it equals. Oops, that's wrong. Okay, so that should have been the square root of 9 minus x squared. Okay, and then I have to evaluate f of the square root of 9 minus x squared. What will that look like? Okay, parentheses. The square root of 9 minus x squared squared minus 9, right? See how this expression right here, we wrote that expression, but we replaced the x with the square root of 9 minus x squared. Okay, now simplify. What happens when we square that square root? They cancel each other out. So now that's 9 minus x squared minus 9. Okay? So the 9's cancel, and you have negative x squared. Now, if I was asking for the domain of a function, negative x squared, I would definitely say all real numbers, because there's no dividing and there's no square roots. But because the g of x did have a limited domain, you always have to consider the domain of the inner function, because that's what you're going to do first. You're going to plug something into the inner function, and then its output will go into this function. So even though it looks like everything canceled, the domain of our composition needs to be, whatever that is. You have to take into account both. If that had some restrictions, then we'd have to take it into account. If that has some restrictions, we have to take that into account. So it's not just as easy as looking at that. So how do I figure out what's the domain of the square root of 9 minus x squared? Good. So we're going to say 9 minus x squared is greater than or equal to 0. Then what? Factor 3 plus x. 3 minus x greater than or equal to 0. Right? If I do the critical numbers, then I have negative 3 and positive 3. And I could test 0 in the middle. Would this expression be positive or negative when x is 0? Positive, right? It'd be 9. So it's actually, this thing is greater than or equal to 0 when x is between negative 3 and 3. So that is the domain of the inner function, which is g of x here. So that's the domain of the composition. Right? So we would say, if you want to say it as domain, you could go negative 3 to 3. Yeah, always look at the inner function. Always consider the domain of the inner function right? And then it goes without saying that you have to look at the composition. I mean, if the composition had to divide by a variable, you'd have to say it, right? But that's the one I think is more obvious. Still you check that, but make sure that you check that.